The multicast examples we've considered so far are all within the same network, within the same autonomous system, and we define an autonomous system as a network under a single administrative control. Now the question is, what if I want to communicate to another autonomous system? Maybe I have a multicast sender sending out a video stream, but there might be receivers in other autonomous systems, maybe partner companies, maybe other locations in our large company, maybe somebody across the internet. And the answer is we can use MSDP, Multicast Source Discovery Protocol. And the big benefit of MSDP is it lets us share our multicast stream with other autonomous systems while not sharing our RP. We can still maintain our rendezvous point locally and secure it locally, maybe filtering out anybody we don't want to communicate with that RP. But we can have our RP share information with RPs in other autonomous systems using MSDP. Specifically, we're going to form a peering relationship between the RP in our autonomous system with RPs in other autonomous systems. Let's walk through an example. Let's say we're in PIM sparse mode domain 1 with autonomous system 64,500, and source 1 is a multicast sender. It's got an IP address of 203.0.113.100, and we're going to be sending to a multicast group address of 234.1.2.3. And as normal with PIM sparse mode, when it starts to send traffic and it goes through its switch and up to router R1, R1 is going to register that group with the RP that it knows about, which is RP1 in this case. But here's where it gets different. After our local source registers with our local RP, our RP is going to then advertise this multicast group out to other RPs and other autonomous systems. It does that with an SA message, a source active message. And now we have an MSDP peer. And RP2 is going to check its multicast routing table to see if there's a *G request to join the group of 234.1.2.3. And let's say that we find that receiver 1 in domain 2, it does want to receive traffic for that multicast group. And that's going to be possible with MSDP. So what RP2 is going to do, it's going to send an *G join message back to RP1 in our domain saying, yes, I'd like to receive that traffic for the *G entry of 203.0.113.100, the source, sending to a group of 234.1.2.3. And now as our local RP, RP1, receives traffic from our local multicast source, it's going to go over to RP2, which is then going to relay that traffic down to the receiver. This is allowing us to send multicast traffic between these different domains without having to have routers in other domains register with our RP. They can register with our local RP. We can maintain local administrative control of our RP and still get the multicast traffic to them thanks to MSDP.